Thevenin's theorem. Thevenin's theorem states that any two-terminal linear network having a number of voltage sources and resistances can be replaced by a simple equivalent circuit consisting of a single voltage source in series with the resistor, where the value of voltage source is equal to the open circuit voltage across the two terminals of the network, and the resistance is equal to the equivalent resistance measured between the terminals, with all energy sources replaced by their internal impedances. If we have a circuit having two voltage sources, that is V1 and V2, and the resistances R1, R2, then we need to find out the voltage across these two terminals, that is V, A and B. Then this can be replaced by a single voltage source in series with the resistance between the two terminals A and B. And this voltage is known as Thevenin's voltage, and this resistance is known as Thevenin's resistance. V Thevenin's is the open circuit voltage across the two terminals, and RTH is equivalent resistance measured between the two terminals. Now, in this, VTH can be found by using any of the network reduction techniques. To find this RTH, we need to replace this with the internal impedances. We need to short the voltage sources and open the current sources. This is R1 and R2 between the terminals A and B. Now, RTH equals to R1 in parallel with R2. If you consider this current as I, then VTH equals to voltage across these two terminals. So V1 minus IR1, since this is positive and this is negative, and positive and negative, or V2 plus IR2. For this network, now I am given numerical values to find the Thevenin's network having the Thevenin's voltage VTH and Thevenin's resistance RTH. So V1 is 50 volts, VT is 25 volts, R1 is 10 ohms, R2 is 5 ohms. We need to find out the resistance between the terminals A and B. Now I am assuming a current I1 through the loop, then applying the KVL. It is 50 volts minus 10 I1 minus 5 I1 plus 25 is equals to 0, or else 50 minus 25 equals to 15 I1, from which I1 equals to 25 by 15, that equals to 1.67 amps. Voltage across 10 ohms, that is V 10 ohms, is given by the current in this, that is 1.67 amps multiplied by 10 ohms, that is 16.7 volts. Similarly, voltage across 5 ohms is given by 1.67 into 5, that is 8.35 volts. Find out the VTH, or the voltage across the terminals A and B, open circuit voltage across the two terminals of the network. That is 50 volts minus the voltage across 10 ohms, that is 16.7 volts, or 25 volts plus 8.35 volts. So in both the cases, we'll find that VTH equals to 33.3 volts. This value is 33.3 volts. These are Thevenin's voltage. Now let us find out the value of RTH. Then the circuit RTH is the equivalent resistance measured between the two terminals with all the energy sources replaced by their internal impedances. So we have the voltage source, so I am short circuiting these two. These are points A and B, 10 ohms and 5 ohms, both are in parallel. So RTH is equals to 10 ohms is parallel with 5 ohms. Then 10 into 5 by 15, which is equals to 50 by 15, 3.33 ohms. This is our Thevenin's equivalent circuit for this circuit. For the shown circuit, obtain Thevenin's equivalent circuit. And this circuit contains a dependent current source. When the dependent source is there, then RTH can be found by using the formula, that is RTH equals to open circuit voltage divided by short circuit current. This open circuit voltage is nothing but the Thevenin's voltage. Finding open circuit voltage. Since it is open circuited, the current passes through 2 ohms only. This is our Vx. By using the nodal analysis, Vx minus 4 by 2 ohms equals to 0.1 Vx. Vx equals to 0.1 Vx into 2 plus 4. 0.2 Vx plus 4. Then Vx minus 0.2 Vx equals to 4, or Vx equals to 4 divided by 0.8, or 1 by 0.2 equals to 5 volts. This is 5 volts. Now RTH we need to find out. Finding short circuit current. The terminals are shorted. The current source is open circuited. This is short circuit current ISC. 4 equals to 2 into ISC plus 3 into ISC. Then ISC equals to 4 divided by 5, that is nothing but 0.8 amps. Now RTH equals to VOC, that is open circuit voltage, divided by short circuit current, that equals to 5 divided by 0.8. This is nothing but 6.25 ohms. This is 6.25 ohms. These are Thevenin's equivalent circuit. Now here also we have the dependency source. Then RTH can be found by using VOC divided by ISC, where VOC is nothing but VTH. Then our equivalent circuit will have RTH and VTH between the terminals A and B. Now obtaining VOC within the terminals A and B. VOC, this is my VOC, then VOC equals to minus 4 VI is going to appear upon this, minus and plus in opposite directions. Then where VI equals to, in this loop, minus 4 VI minus 5 volts, 5 VI minus 5 VI equals to minus 1. Then VOC or VTH equals to minus 4 of minus 1, that equals to 4 volts. VTH equals to 4 volts. For finding ISC, four VI plus the current is ISC, 2 ISC equals to 0. If you observe this, the voltage 5 volts is going to appear parallel branch. So we can say VI equals to 5, but this voltage is in reverse direction to this voltage, so minus 5. Now substitute this, you are going to get minus 20 plus 2 ISC equals to 0. Now ISC equals to 20 by 2, that is equal to 10 amps. Then RTH is given by VOC, that is 4 volts, divided by ISC is 10 amps, that equals to 0.4 ohms. RTH is 0.4 ohms. This is our Thevenin's equivalent circuit.